You gonna show how to swap two references? Sure. I mean, today's all about examples. If you want to see that, we can do exactly that. You realize you might not have seen a swap method. There's a standard way to swap in programming. You might not have seen it in 115. I'll do a real quick explanation. You create a temp variable, store one of the values that you want to swap, and then assign each of the variables, assign the other variable to the first, assign the first variable to the second one, and the second one to the temp variable. But you do have to have some temp storage to be able to swap between two values. Can I leave personal comments in my own code? Yeah, why not? Okay, so let's get into this. First, we got to talk about lab. I'll try not to talk about lab too much, but the most important thing I want to say, and I did update the lab post on Piazza with some commentary from myself, but I want to make sure it's said in lecture. It's okay if you did horribly on that lab. That is not a problem at all, and it most likely will not affect your grade. As long as you attempted the lab, you did work at it for 2 hours, and made a submission on Autolab. If you made a submission, at least one submission at the end of that 2 hours, that's perfectly fine. So the way the lab is assessed is through the application objectives. So each homework assignment has an application objective. You choose one of these two, and that's one of your 5 homework assignments for the learning objective, for the program execution learning objective. It's that application objective. So your goal with an application objective is to prove to me that you've met this objective, which is, can you apply the learning objective to solve a real world problem? Your goal with the application objectives and the learning objectives, the same thing applies, is to convince me that you've completed that objective. That's your goal in this class. Convince me that you've completed all 5 learning objectives, meaning you can do all 15 of those bullet points, and then prove to me that you can apply what you've learned through the learning objectives to solve real-world problems. So in assessing your application objective for your homework, I'm going to take your homework submission, your latest one before the deadline, and your homework interview with your TA. You'll have a verification interview with your TA the week after the homework is due, and also your pre-lab, your pre-homework in lab. I'm going to take all that information, look at what you've done, and then decide if you've actually completed that learning objective. I'll make one of 3 decisions when I get to that point. Either no, you haven't completed this and you didn't try, and you flat out didn't get it. You're not getting that application objective. You completed it and you're fine, which for today's topic, for what I'm talking about here, if you complete the homework and crush the interview, you get the 1 in Autolab, and you crush the interview, and the TA's like, man, they knew their stuff. I'm probably not even going to look at your lab. That lab isn't going to factor into my decision making. But if there's a borderline case, if there's something where the third option can come in, is you didn't quite complete it, but you did try, you didn't do so bad that it's a no. In those cases, I'm going to give you makeup opportunities. I'm going to say, I think you can get this if you give it a little more time. So I'm going to give you that extended deadline. If I'm making those borderline decisions to decide whether you get the extended deadline or not, or maybe a second interview opportunity or not, that's when your lab is going to come into play. I'm going to say, well, how much did they really try? If I look at the lab and you got a 0, but you did try for 2 hours and you put in an honest effort, but you just didn't quite understand how testing works, which is perfectly fine. This lab is meant to show you what I mean by unit testing. It wasn't meant to assess your understanding of unit testing. So I'm going to look at that and be like, well, they gave it a try, and they did have good tests like the day after lab. They actually wrote some really good tests. So they, were studying and they understood what they had to do and got it done. That's going to look really good. If you got a 0 on the lab, as opposed to if you got a 0 on the lab, you made 1 submission only, it was 15 minutes into your 2-hour period, and then you ghosted me and just gave up. That's where I'm going to say, come on, man. Are you trying? You got to put in your hours. You haven't done that, you're not getting an extension. So as long as you've tried and you still got a 0, which, by the way, most of the class got a 0 on this lab, that is not a grade. There are no actual grades, points, score. There's none of that in this class. It's 1 if you've completed an objective and a 0 if you didn't. The numbers are pretty meaningless, though. So if you got a 0, don't panic. I'm going to look at the level of effort. Not all zeros are created equally, especially on this lab. So, for example, if you just didn't quite understand what the assignment was asking and you kept getting incorrect fails on a correct solution, and then you just get the 0 for that objective, don't sweat it. As long as you're working and studying and trying to get better, you're going to be in good shape. So no panicking. There's a lot of panicking going on right now. I do understand that. I hit you hard early in the semester. There's a lot of content that comes at you fast. And I just threw a new language at you. That's no small thing. I expect you to be struggling a little bit here. And that's why we still haven't had anything that, we still haven't hit any major deadlines that affect your grade yet. Everybody's still in the running for an A until the first homework deadline. Yeah, I definitely got you panicked over 3 weeks, but now is when I want to start. Now that you're exposed to the course and you kind of know how things are working with the course a little bit, this is when I want to start talking about the grading structure and how the grading is structured for you to focus on your education and your learning and not sweating if you weren't able to finish this lab in 2 hours. That should be the least of your worries. As long as you put in 2 hours of work trying to write tests for the homework assignment, that's what I want to see, and that's the goal of this lab, was to show you, get you thinking about the homework and giving you a good start on the homework so you can not start it on the day of the deadline, and also showing you some of the tests and some of the expected behavior of the homework assignment. That said, I opened the lab link. This is the link that you get. I'm not logged in. This is the link you got after you filled out the submission, the starting lab form. If you didn't finish the lab, I strongly recommend finishing the lab before doing the homework. If you're diving into the homework without those test cases, it's going to be pretty tough. But if you go through the lab, which is kind of guiding you and showing you how to test these objectives, that's going to make writing the homework itself a lot easier. So, and I'll leave the lab grader up on AutoLab. When we do the application objective assessment, we'll hold much more weight to your last submission within that 2-hour window, but we'll still look at your lab score, a few days out after the lab. If you went back to the lab and finished it over the weekend or on Monday or Tuesday even, I'm still going to see that when I grade your application objective. It's still going to look good for you. Much better than never doing the lab. If you make it to the homework deadline without having any lab code, you're probably not getting an extension. Unless you finish the homework and you don't need the extension. Okay. With all that said, so you can still go through the lab. It's basically the time limit's removed, and you can still use that to help you get started on the homework assignment. So hopefully with that, everybody can breathe again and relax a bit. 220 is in C and 250 is in Scala. I missed a lot of chat in there. It looks like there's some chat that I don't need to respond to, some side talk. So I'm going to assume most of it's that. Let's introduce this lecture question, then I'll go back to Wednesday's slides and talk about those examples some more. So, the battery question. So this is the one that I said I didn't like. I did change it. I cut like half the question out. But I still do like this question because it's talking about references a lot. It's really testing your understanding of references and how objects move around in your program. References to objects move around in your program. So with this, create 2 classes, one called battery, which in its constructor takes a charge as an int, and this is a variable it's going to change. And that's it. This is just a class. We're going to create objects of type battery, and the only thing they do is hold a charge. They don't have any behavior. There's no methods, nothing. All they're doing is holding a charge. Another class named flashlight, constructor that takes no parameters, but when a flashlight is created, create a state variable named battery. This is in quotes. This is a legit name, so you can use it in your testing. The variable named battery that stores a battery a new battery with a charge of 5. So when you create a new flashlight, you should create a variable named battery that stores a new battery with a charge of 5. So the flashlight has batteries included, is what we're saying here. To do this, remember any code outside of all your methods is executed right after the constructor is called. So this constructor won't take any parameters, but when the constructor is called, we're going to call this code, which is going to be outside of any of the methods, that creates your state variable named battery, set it equal to a new battery with a charge of 5, and then you have batteries in your flashlight. So I have two methods. One, use, which is going to simulate using the flashlight. It doesn't return anything, and it's going to decrement the charge of the battery by 1. If the battery already has no charge, this method does nothing. It's not going to change the charge of the battery if it's already 0. The battery's already depleted. Nothing else to do there. And finally, replace battery. This is where it gets tricky. This is where the swap question came from in chat. Replace battery is going to take a battery as a parameter and return a battery, and it's going to swap the batteries. So I have a flashlight. It has a battery in it. I have a battery that I want to replace, and I'm going to literally replace these batteries. Add this battery into the flashlight, remove this one from the flashlight. And we need to check the references to make sure that this swap is happening by reference. We don't care if just the charge is correct. So if you're just checking the charge of the batteries after the swap, and if you're just checking the charge of the battery after it's being used, that's not all of what we have to test. We have to make sure the references are being followed. When we use a flashlight, we don't want a new battery being created with the proper charge. I don't care if it has the right charge. I care if it's that actual battery. If I have a flashlight, create a flashlight, comes with a battery, and I use it, it should be that battery, that exact battery on the heap that's depleting its charge. So with replace battery, following the references is the key point here. Whatever battery was the parameter of this method, after the method resolves, after that stack frame is off the stack, the battery in the flashlight has to be the same exact battery by reference as the one that you gave this method call. And the battery that this method returns, you need to check to make sure that's the battery by reference that was in the flashlight. That's one of the things that a lot of students last semester didn't check, is replace battery is returning a battery, and you have to make sure by reference that that is the battery that was in the flashlight. So we're checking references. And then a test suite tests batteries to test all of this functionality. Without this, implementing the methods is fairly trivial at this point in your careers, except the swap, as was mentioned. We can. So with this one, I would store a reference to the battery that's in the flashlight. The flashlight's battery, store that in a temp variable of type type battery. Then the batteries, this dot battery, set that equal to the parameter, and then return the temp variable, which is storing a reference to the old battery that you need to return. But implementing these methods, pretty straightforward. It's the testing. How do we test to make sure all of the references ended up in the right places as we called these methods? That's the trickier part, and that's where a lot of your work is going to be in writing the tests for this one. No slides brings us back to the lecture question. And I've mentioned this before, but I've worth repeating. I usually don't show these in lecture, but I'll sometimes have bonus slides after the lecture question, after the end of the slides, that gives you kind of some hints and some more clarification on the lecture questions. So if you're not looking for those, make sure you're looking for those. Make sure you're going to the end of each slide deck and checking out the bonus content that I don't show in lecture. That can help out. So let's go back to this example. I want to bring this up real quick. Oh, my computer restarted, so I have to fire up some of my stuff again. Let me get IntelliJ thinking about running. So we saw this example. We saw how characters in the party were added to the heap, added to heap space, and how the references move throughout the program. what I want to show you is the same thing, this execution of this program in IntelliJ. So it looks like IntelliJ has decided to run for us. Let me move a few things around. Okay. In Bird Box, if you want to see the Bird Box example, I actually added this to the end of Wednesday's slides. It's an old example. It covers the same content as the RPG example, but it needed to be updated. So get ready for this magic. This is something I'm going to talk about throughout the semester. I've started bringing it up in office hours, and I'm going to talk about it in office hours and in lecture throughout this semester, and the TAs will be doing the same thing as well. I'm going to click over here. For this example, I'm just going to start at the first line of my main method. Click over in what we call the gutter over here, which is going to put a red circle there called a breakpoint. And now, when we run this program in what's called the debugger, we're going to see a debugger today. Instead of running my program using the play button or choosing run here, I'm going to choose to run the debugger either right here, or if this is the last method that I've ran, the last class I've ran, I can run it right here. But I'm going to run the debugger. If you haven't seen this, get ready. This can save you all the time. So what is the debugger? So what the debugger does is runs your program one line at a time and shows you the state of memory at any given point in time, and then lets you step through your program one line at a time. So this is the state of memory as the program first fires up, and I'm going to click this step button to step through the execution of my program one step at a time. I get this nice information right on the editor itself, and I also get this display, which is going to show me the state of the stack and following references to go to the heap throughout the execution of this program. This is something that can cut your debugging time tremendously. If you're trying to just stare at your code and trying to figure out what's going wrong, you wrote some unit tests, that's a good first step. You wrote your unit tests and your tests are failing and you just don't know why. Running the debugger and stepping through your program and seeing all of the values of all the variables, it can expose a bug ridiculously fast. So here I have two variables on the stack, mobxp, bossxp, with values 20 and 100. And I can see the stack right here, all the methods that are being called. Right now, I only have the main method on the stack. I got this -1, not entirely sure what that means, but I think it's just overhead for the program. And then my main stack frame and the values that I have here. I have the command line arguments, which are nothing right now. I have a reference to the calling object, which actually is the RPG main object, which we don't use, doesn't have anything meaningful, and all the values that I put on the stack. Now let's step through to the next one. I'm going to create a new party character and store it in a variable. The right-hand side has to get resolved before I can create the variable and assign it that value. I'm going to take one step forward, and we're going to get into the constructor call of this object. The constructor call is a method call, so this puts a new frame on the stack. I'm inside this constructor stack frame, and I have the variables for this constructor, including a reference to the calling object, which in this case is the object that's being created. Then all the code outside of the constructor and outside of all the methods are called. So we're going to initialize both those variables. We hit the end of the class definition. So we have that stack frame is destroyed. All the variables within it are destroyed. But the reference to that object that was created is returned from that stack frame. So now we can assign that to our variable hero, add that to the stack, and hero, when you look at the debugger, whenever you see an at some number, like we saw in the slides, that means that this is an object on the heap. Whereas mob XP, boss XP, we just have the values straight up. Those are values on the stack, in this stack frame. Hero is a value on the stack that stores a reference to an object on the heap. I know that's a mouthful. Hopefully that's starting to make more sense at this point, though. And if we click these arrows, the debugger is going to go to the heap, find that object, and show us the values of the variables, of the state variables of that object on the heap. It's going to go to that memory location, this at 476. It's going to follow that reference and show me what's going on with that hero. We can step through this next. Oh yeah, when we call win battle, so we put a new stack, a frame on the stack. We used character. We gave character that at 476, the hero variable. So when we called this, we gave it hero and mob XP from the main method, and we can use the stack here, the call stack, to go to a previous frame and go to the main frame of this program. Hero had a reference to the party character stored at 476, and then mob XP is 20. So in the current frame where win battle is being called, I have a reference to a character which is at 476, the same exact character that's referred to by the hero variable in the main stack frame. That same exact character is, I have a reference to that same exact character in this method. So then we call, for example, battles 1. This line is executed. That goes to that point in that space in the heap on the in heap memory, increments battles 1 by 1, and since it went to this reference, it went to that exact location on the heap. If I go to my other stack frame, I can see that the hero incremented its battles 1 because that's referring to the same location in memory. So as soon as this line was called in this stack frame, we can see that change reflected in the main stack frame because they're both referring, even though they're in different stack frames, they're both referring to the same location in heap space. So we can see that change right in the debugger as it's happening. And then increment the XP, stack frames destroyed, back to the main stack frame. Go into party character again to create a new character. Returns. Create a new party. Run battles 1, initialize that, skip the method definitions, get to the end, return that stack frame with a reference to the object that was created, and assign that to the party variable. And we can verify, if we look at party, the character 1 should be the hero. So if I look at character 1 at 476, it's the same exact reference to the same exact character. So even if two characters have the same battles, the same values for battles 1 and experience points, they're not the same character unless they refer to the same exact object. So, let me go through a little bit more. Actually, no, I'll say that right now. So if I have two party characters, if I have two objects of an object type that I've created by writing my own class, if I use the equal operator on them, so if I said something like hero print line hero equal party dot character 1, this is going to be true. Because when we use equal on objects of a type that we created, it's going to compare them by reference. So the hero and party character 1 both refer to the same object on the heap. So this is going to return true. So for Wednesday's lecture question. It was in the bonus slide, but I didn't mention it explicitly in class. And today's lecture question, this is how you can compare the references of objects. When I say make sure that's actually the same battery, you have to have a reference to the battery you expect it to be, and then a reference to the battery that it actually is, and make sure they're equal. Make sure they're the same exact battery. Don't do battery.charge equal other battery.charge. We don't care if the charges are equal. We care if they are actually the same exact battery. So that's how we can compare references. Take two references and just say are they equal. That's going to check them by reference. Do these two variables refer to the same exact object? When we call win battle inside party, where we have a reference, this is going to store a reference to the party at 479. If I go to my main method, that party stored in the variable named party is at 479. So it's passed a reference to that party and stored it in the keyword this. So I have a reference to that same party. I have references to the same party characters. And I can see all that same information. These are the same exact values on the heap as I have in the party and hero variables in the main stack frame. But I have the same references in this win battle stack frame as well. XP is 100. Then we go, let me expand this. And then we go into each one of these objects. We follow the references and update all the appropriate values. And we can see all those values as they change. And of course, those changes are reflected in the main method. We just exited that method call. The stack frame's destroyed. All those local variables are destroyed. But those changes are reflected because they were made by reference on the heap. Because we passed, because we're passing these objects, we're passing them by reference. That's where we get the phrase passed by reference. We're giving references to the methods that we're calling. I don't believe there's a step back. But there are, so these other ones, this is step over. So if I get to, where are we on this print line? If I want to skip a method, I can just step right over it and not go into all the details of it. If I want to step into, that's the one I've been using, that's going to show me every single bit, every single execution, everything that's happening in this program. So step into is going to show me every little thing. There's also step out of. If I enter into, let me start this over. So I got to the end of the program, all memory's freed up, nothing's happening anymore. I'm going to rerun the debugger with a different breakpoint. I'm going to stop right here. So one trap you can get into with this is if I keep stepping into and I hit something like a print statement. Oh, it didn't do it. It did it in office hours yesterday. Oh. But it's easy to get into code that isn't yours. I think it's because we were running a test suite. I think we were running a test suite and we got all kinds of crap. So when you run the test suite, Scala test uses up a lot of stack. It's running a lot of different stuff. And if I go into like an assert, you're going to end up in a library, the Scala test library, which has nothing to do with your code. If you find yourself getting lost in one of those in the debugger, we have this step out, which is going to exit. It's going to run the debugger until the end of the current stack frame. Once that frame returns and is destroyed, it's going to resume back there. So I just want to get out of here. I want to get out of here. I'm going to click that until I'm back to my code, which is what I care about. There's also step over. Like I mentioned, if I just want to skip the next line, I can just skip these ones. And then when I get to the one I'm interested in, step into that one and then check out what's going on in there. Then I get into the library again. These ones ain't too bad. But sometimes Scala tests, you can get like 8 layers deep into the library and just get completely lost in there. That's the debugger. We're going to talk about this a lot. As long as I can get to it, I want to talk about it again today with the next example. Extremely helpful. Go through, for those of you who are struggling, which from the sounds of it is a lot, or most of you, go to the examples repo, and the examples you don't quite get, that you don't quite understand, do exactly what I just did. Fire up that example. Maybe items gave you some trouble. You're not sure how object creation works from classes. Go right to the first line of the main method, slap a breakpoint on there, run the debugger, and just step through the thing one step at a time, and make sure you understand everything that's going on in there. Just make sure you see exactly what's being executed at what point. And then once you're comfortable with that, start changing things. Go into the item. Okay, what if I wanted this to be a method call? Math.abs. I'm just making crap up here, but what if I want to change that? Rerun the debugger. Oops, there's a rerun button I didn't use. I've gotten lost in the libraries. And now what's going to happen? When this is called, this is perfectly valid code. We can call methods inside this code. We can put any valid code outside of all the methods, and it's going to execute. Oh, damn it. Thank you. I can, so I was stepping through the item example and just showing, just go through any examples that you're not quite understanding. Hit a breakpoint on the first line of main, run the debugger. I modified this a little bit to have a method call here. Outside of any of the methods, when you're in this land over here, this code, we can put any valid code here and do any initialization that we need. This is going to execute right after the constructor call. So especially for rhyming dictionary, when your constructor takes a file name for the dictionary, the first thing you want to do is parse that thing. So you can call methods in here. You can do any complicated code you want in this area. I recommend putting your code in a method and then just calling the method in this area. Like I could do this purchase and have an initial purchase happen right at the time of object creation. Let me rerun the debugger just so we can see that. And this code is going to be executed right after the object is created. So the constructor is called. I get this, a reference to the object that's being created, as a description of cereal, as a price and times purchased, initialized from the constructor, and then everything outside of the methods is called. Times purchased is going to, oh, come on, why didn't it? I expected it to go into the ABS method. I'm not sure why it didn't. And then I can call methods that I wrote in this class too. So I can call the purchase method and create at the time of creation. All I did was create this thing, but it was already purchased one time. 2 times as it turns out. Oh, yeah, because I set it to 1 and then purchase. So I actually have an initial times purchase of 2 from the way this is set up. Not sure why that didn't go into the ABS method, but you get the idea. So once you get comfortable with the examples, run them in the debugger, see what they're doing, then start changing things, and just make sure your changes do what you expect them to do. Or if you don't know what a change is going to make, just make a change, run the debugger, and see what it did. That's we call it tinkering. It's one of the best ways to learn. Just play around with stuff, code in this case, and figure out what the hell things do. Oh. So let's digest that for a second. The debugger. Probably the most powerful tool we have as programmers. The debugger. Half of our job, if not more, is finding and eradicating bugs. And the debugger can make that part of your job way, way easier. Still a little confused about how to swap references. So whether they're references or not, you can The standard way to swap. Oops. Def swap. Like if I had two. Let me do it like this. Var x equals 7. Type int. So say I have two variables with values and I want to swap them. The standard thing to do is, oops, I didn't cut it. So I have this task, I have x and y, I need to swap them. Where are their references? References behave just like ints, as it turns out. So this will work in that case. What I'm going to do is create a temp variable. I'm going to set that equal to the value or reference of one of the variables. Then I can safely overwrite that value since I have its value backed up in this temp variable. So I can do x equals y. So assign x the value of 10. So x and y are both 10 at this point. And then set y equal to temp. Now we have them successfully swapped. This is a horrible way to set it up, but so x is 7, y is 10. Store x's value in temp. Overwrite x. And, oh, the debugger, we got to the end of the method, so the debugger wants to move on. But y would be assigned that value 7. More time debugging than actually writing code. That's about how this game goes. This programming thing. All right, so let's look at this example. We start at 150, 240. I'm still getting these. It's not always on the hour plus 50. 240. So let's go through this example and see what's happening on the stack as we go through this thing. Does this solve the reassignment to val error? You can't reassign to val ever. If you need to reassign to a val, make it a var. It's a simple solution there. The only reason you use val is if you never expect to overwrite it. If you never expect that value to change. So let's do this example. Compute the geometric sum of some value, 3 in this case. We expect this to sum up 1 plus 2 plus 3 and return 6 in the end, and then print 6 to the screen. So that's what we expect to happen. Let's see how this happens on the stack. And this is the first time we're really going to crack open a recursive method. So it's still not expected that you'll understand recursion. Specifically, you're not expected to have to write recursive methods yet. But we can go through this example, and as I talk you through this example, I do expect you to understand what's happening on the stack with each new method call. So if you're turned off by the recursion and that's confusing you, don't worry about that yet. Learning objective 3 is when we're going to talk about recursion, and I'm actually going to expect you to write those recursive methods. We're not there yet. Don't worry about it yet. Right now you should be worrying about what's going on in memory, what's a stack, what's a heap, and how do I write unit tests. That's your goal right now. So let's go through this program. We're going to get to this first method. We want to declare this variable and assign it a value, but first we have to evaluate the right-hand side and resolve that to a value. And that's where most of this program is going to happen. We're going to call this method compute geometric sum. Every method call is going to create a new stack frame, a new environment for its execution that can't jump across stack frames unless we're accessing the heap. Unless we're following references and accessing heap space. That's the only time two stack frames can affect each other. So, yeah, I do what I do. So we're going to create that stack frame for this method call. We're going to take the parameter and assign it to the argument. So we have on this new stack frame a variable named n storing the value 3. So the first thing we do, create a stack frame. The first thing we do after creating the frame is create space, allocate space for the parameters and set them equal to the values of the arguments. So we're in compute geometric sum. The main stack frame just has to sit around and wait. We're going to enter this if block. So we start not necessarily a whole new environment, but we're going to start a new space in the stack where variable names can be the same. Though I didn't reuse variable names. I should have, just to make things clear. But we are going to enter this new block. And when we enter that new block, the first thing we do, since n, we're going to check n, 3 is greater than 0. Enter this. First thing we do here is create a new stack frame for compute geometric sum again. So we're actually calling the same method that we're currently executing. So we're going to put a new stack, a new frame on the stack for the new method call and do the same thing. Assign its parameter equal to the argument. The argument is n minus 1. So in this new stack frame, we're going to have a variable named n with a value 2. So we have two variables of type n. We're tempted to panic, but don't worry, they're in different stack frames. Not even just in different blocks, code blocks, they're actually in completely different stack frames. So we have no issue here. Next, okay, n is 2. That's greater than 0. Enter the block again. Call geometric sum. 2 minus 1 is 1. So we're going to create a new stack frame for this new method call, assign n to 1, and add that to the stack. So we're 3 stack frames deep at this point in this execution. When the value is 1, 1's greater than 0. You can see how this is repeating. 1 is greater than 0. We're going to put a new frame on the stack with 1 minus 1, 0. So we enter the if block, add a new stack to the frame, n is 0. And now finally we get to do something different. N is 0. That's not strictly greater than 0. So we're going to hit the else. The else does nothing but return 0. So now we can finally start peeling frames off of the stack again. This stack frame, instead of adding a new frame to the stack like all the other stack frames did, this stack frame is finally going to return. So this stack frame is going to resolve to 0. It's going to be destroyed and return that value 0 to the calling stack frame. This stack frame that called that method inside this if block now finally got the value 0 returned here. Create a variable named result, assign it the value 0, put that on the stack. And now we can continue the execution of this. We're going to compute result plus equals n. So result, we're going to look for n in the current block. We're not going to find it, so we're going to expand our search, always staying within the stack frame, but we're going to expand our search to the next outer block. So in this stack frame now, we find a variable n. It has value 1, so we're going to add 1 to result. And now we get to return result. Now we get to return result from this stack frame. So this stack frame, it didn't hit the else, it didn't just return 0. It executed this code, which include calling itself through a new stack frame. But once that returned, it's able to execute the rest of its code and then return that value. So result is being returned. Result is 1, resolves to 1. So we return that and give that back to the previous stack frame. This stack frame is destroyed. It returns 1. We create a variable named result, put it on the stack, assign it the value 1, and continue within this stack frame. Now this stack frame can continue its execution. It was sitting on the previous stack frame to resolve its call to compute geometric sum. Once that resolved to a value, it's able to use that value and go on with its program. So result plus equals n. Result 1, n, travel not found within the block, so travel outside it, but stay in the stack frame, is 2. So importantly, we're not exiting the stack frame. So we're not finding this value of n. We're finding this one inside this stack frame. That value is 2. So result is going to be 3. And that's what we get to return to the next stack frame. That stack frame was waiting for compute geometric sum to return, but its value of n was 3. Its result is going to be 3 because that's what the other stack frame returned. Now we get to add 3 plus 3, 6. And this, finally, we get to return back to the main method. We're going to return this value 6 back to the main method. It can store that in its variable it's going to create named result, and just print it to the screen. Yeah, TAs would be happy to go over office hours. We're also going to get, a few of the TAs are going to get review sessions rolling, weekly review sessions. They're setting up the logistics of that, so you can go over more examples. John never showed up. Unfortunately, when you're in the queue for office hours, in Zoom at least, you can't see where you are in the queue. You just have to wait and hope. In my office hours, I like posting in the chat on Zoom. I'll say how long the queue is so you can get at least a rough idea of how long you'll be waiting. And then at the end of the program, we're going to free up the memory, and the program ends. So with that example, you might notice that we got close to the end of the stack. Note that in reality, this isn't going to happen. Stacks are much, much, much larger than what I can fit on a slide. So I'm just simulating, like, what if we had this really small stack. In reality, you don't have to worry about running out of stack space. You're going to have tons of stack space. The only way you're going to run out of stack space is if you break stuff. If you're going infinite, then you're going to break stuff. So guess what we're about to do? So what if this were our code? Instead of having an if n less than 0, or if n greater than 0, do this, else just return. What if we always put a new frame on the stack? What if we always had geometric sum called geometric sum? So let's jump to the execution where we hit our conditional and say we didn't hit our conditional. Now we have n of 0, compute geometric sum of -1. We're going to put a new frame on the stack. That's going to put a new frame on the stack with -2, n equals -2. That's going to put a new frame on the stack with -3, and it's just going to go on infinitely. It's going to run, it's going to do that forever. Yeah, this is what we call infinite recursion. So what happens when you don't have a condition in your recursive call that doesn't make another recursive call? If you're always making another recursive call, you're going infinite. You're getting that stack overflow error, the namesake of our favorite website. You hit the end of the stack, you're trying to use memory that's used by another program that you're not allowed to use. The OS is going to say you can't do that. The JVM is going to say you can't do that. Your program crashes. Stack overflow error. You can't use it. That's what happens when you use up all the memory that was allocated for you for your program for the stack. You used it all up and you tried to use more. It's not allowed. You can't do that. Program crashes. I said the thing. And I'll show it off again there. So with Wednesday's lecture question, there was a bonus slide showing you how to compare references. You want to call play game, but you can't access the offense, defense, or score of these teams. You have to test them by calling declare winner and using equal equal to check the references. Did this return the reference that I expected? In this case, team T2 should win. So whether I call T1 T2 or T2 T1, declare winner should always return T2, and I can check that with equal equal. You know, I always forget this ends at 240. I had to check my math there. And then I do have an extra example. This is in the repo if you want to go through my bird box example. This is the one I used to do instead of the RPG one. Was it only that many slides? Oh, no wonder I didn't like it. And I gotta move this over. And really quickly, I want to run the debugger on that second example, the one with the stack overflow. And we can see as an example. I had an error in an unrelated file, and it's still going to break the one that I'm trying to run. So let's step through this a bit, get some good stuff on the stack. And we can see that right here, I just clicked enough till I got to compute geometric sum of -12. N is -12. This doesn't really matter. It's the object itself. That's technically the calling object when it's an object declared as an object and not a class. If you're from Java, that's similar to calling a static method. But we keep getting to this line and calling compute geometric sum again. So if we look at our stack here, we can see all the stack calls. We can see this stack frame is waiting for compute geometric sum to execute, and it has an n of -11. So when it called compute geometric sum, it called it with -12 and put that -12 on the stack. This was called from the one with n of -10, -9, so on and so forth, till we get all the way back to our main, which is waiting on compute geometric sum of 3. So our first call has an n of 3, and just kept adding frames to the stack, adding frames to the stack, adding frames to the stack. And it just it'll keep adding them forever. So, or not forever, but theoretically forever. Practically in the real world, we're going to run out of stack. So if I just click resume, this is going to keep running until it hits the next breakpoint, which it's not going to do because we're going to get the stack overflow error. So this is every frame on the stack propagating the error upward, and each one is going to print out what the error it received was, and then pass it to the next frame. So that's how many frames were on the stack. I'm not going to count them. But we have a lot of frames on the stack. Ran out of stack space. Program crashed. All right, so that's officially the end of lecture. And let's do some chatting. And it's just like Wednesday's lecture. I really like this lecture because we're more digesting at this point. I'm not throwing brand new stuff at you. I'm not throwing another new language at you. We're just digesting what we've learned already and really seeing the implications of the things that we've learned. So hopefully, I'm hoping y'all start feeling better, that these lectures are designed to make you feel better about the content. So hopefully that's working. Can you explain about first team wins ties? So, can you explain about first team wins ties of last homework? It's not the first team that wins a tie, though. It's if there is a tie, neither of those teams win. So if there is a tie, you're creating a new team object and returning that. And then your tests should check by reference. So like if this was set up where these two teams tied, I would have a test that says declare winner of T1 T2 not equal to T1, and then call it again, declare winner of T1 T2 not equal to T2. As long as it's not doesn't return T1 and it doesn't return T2, it must have returned some other team, some new team. I don't care what it is, but that's how we're indicating a tie in this this lecture question. I'm stuck on the dimension swap test on vectors. Dimension swap, I swapped like a y and z, I believe. So make sure you're checking x, y, and z, and make sure you have distinct values for each of those. Like if your vectors are 1, 1, 1 and you add 2, 2, 2, you're never going to write a failing test with those inputs for dimension swap. That's to make sure that you check all x, y, and z with unique values. And I'll often give away, like if you're stuck on something like that, I'll often give away what the incorrect test case is, especially early in the semester. Do you use Docker for Autolab? Autolab itself uses Docker, but my grading code doesn't, if that's what you're asking. But Autolab runs Docker. So every time, so even when I have a really simple lecture question, you'll notice that there's like a 15-ish second delay from when you submit to when you get your grade. That's because it's spinning up a Docker container to run your code in isolation. So you get a brand new, fresh Docker container to run that code. It spins up. That's what takes the time. Then it runs your code. That takes less than a second usually. The grading code against your code, and then that returns and gives the grade back. It's all happening in a Docker container. That's how we avoid you being able to do rm/rf slash, or what did I say? rm/rf slash. That's what's preventing you from doing that. So you can do that, but you're just going to destroy that Docker container that was specifically created just for your one submission. And then it gets destroyed right after your submission anyway. So you always have a perfectly clean Ubuntu environment to run your code for every single submission. Oops. Can you please explain why the physics homework Y isn't the vertical dimension? I've gotten into this argument before. It's so the dimensions. I mean, it's up to when you're creating your own world. You can choose wherever the dimensions go. And for what it's worth, the two most popular game engines, at least for indie developing, Unity and Unreal Engine, they don't use the same axes. They don't even agree on what axis is up. I forget which does what, but they are not consistent. You can just make up whatever you want. Students also got really upset with me the first time I rolled out this assignment because the value for gravity is not negative. But the negative, so the gravity is just a magnitude, not a direction. Negative is the direction. That's making that a vector. So we don't do negative g for this assignment. Keep that in physics class. For interview, should we have a thorough comprehension of how our code should run in a stack heap? I guess it depends which interview. My general answer is just, yeah, you should always know. Even if it's not an interview, you should know just because you should know. Like that's something that'll help you write your code. If you don't know that, if you can't step through your code and do what the debugger does, basically act as the debugger and show the stack and heap memory, if you can't do that, you have some misunderstanding about the course material, and that's going to lead to longer debug times when you're fixing your programs. That's when you get, I worked 30, 40 hours on this assignment and got nowhere. It's usually because of some fundamental misunderstanding at that level. You should always be able to do that. For the interview, it's going to depend on which one, whether the TA is going to ask you about that or not. This upcoming week, next week's lab is an interview and a Thursday lab. The interview is going to be about this learning objective, and they're definitely going to ask you about stack and heap. For the following week, it'll be a homework 1 interview and the homework 2 pre-lab on Thursday. The homework interview, they might not ask you specifically. They'll ask you, like, when you create this object, is that going on the stack or heap? Possibly questions like that, when you should be prepared for that. But they probably won't ask you to walk through every step of the execution of your program and talk about stack and heap, because they'll have other questions to ask you, and that would take up a lot of time. If they have time, they might. Next week's lab on Thursday, you can sure bet that I'm going to give you code and say, talk me through the stack and heap throughout the execution of this program. Can you please go over the recursion stuff again? Let me move chat over here. I can. Let me try to get to live. If you have a more specific question, I can try to answer it. But let me try to get to the live questions, live chat, before I get into another example. Where the hell was I? Oh, here. For Wednesday, I couldn't pay. Negative numbers allowed, but I can't access the score to show if it went below 0. It will be 0. So you have to set up a situation where that's going to matter in terms of who's going to win. So set it up where one team should win, but if negative scores are allowed, the wrong team wins. So you have to set up your test in such a way to get that situation. Like if you have somebody with 0 offense, a team with 0 offense and 1 million defense, they shouldn't be winning any games. But if you give them a team with like 2-2 and you allow negative numbers, then that team with the high defense is going to win. So just give a team with really high defense and make sure. Actually, I think this example here, if you just code this one, I think it will. T2 should win anyway. That one doesn't work. But if team 2 had an, because this is 0-1 is the score. Yeah, no, that would work. Because so if you lowered this 4, if you had this like a 3 or less, then it's going to be 0-0, and this should return neither T1 or T2. But if negative scores are allowed, Team 2 is going to be the winner because Team 1 is going to have a huge negative score. But for any of the test cases, you just got to set it up in a way where it's going to matter in terms of who wins the game for this lecture question. There's some variables we can't access in today's lecture question. I always get an error in testing. I believe I named them all for today's lecture question, which is kind of a trap, to be honest. So when I didn't name them on Wednesday's lecture question, you don't fall into the traps of using the variables. So if you, for example, for this lecture question, if I named all these variables, you'd be tempted to say referee.declare winner, store that in a variable, and then make sure its offense, defense, and score are what you expect. But that doesn't check the reference for you. You don't know if that's actually the same team, or is it another team with the same offense, defense, and score. So I eliminated that trap and forced you to check the references by not naming those variables. That was very carefully designed. With this lecture question, the battery one, I do name the variables, so you're more tempted to just check the charge instead of actually checking the reference. So this one is a bit more trappy because of that. And that's what a lot of students get tripped up on in this question. They think, oh, I have access to charge, I'm just going to check the charge. No, you still have to check the references. I'm just giving you this red herring of, look, you could check the charge. Are you tempted to check the charge? Which you do also have to check the charge to make sure it's being decremented by 1 properly and then zeroing out. But you also have to check all these references of the batteries. So don't get caught up in that and only check the charge. Maybe a reference to what lecture covered this? Not you. Oh, I missed something there. I lost my spot. AutoLab somehow let you see the whole process? For what? AutoLab shouldn't tell you much. It'll tell you all the files of your zip file that you submitted, and then my feedback. It shouldn't show you more unless I upload the wrong grader. I sometimes do that. I sometimes accidentally upload a grader with all of the details, which I can't do. I kind of wish I could do that, but the problem is when I've done that in the past, what students do is write code to find my grading code and then print that to the screen, and then they read their output, look at all my grading code, and then don't actually do the assignment, but they just hard code my test cases and do some ridiculous stuff like that basically ensures that they don't learn anything. So unfortunately, I do have to hide all that output, but I might have made a mistake. I have a question on how to call a method from an object in the testing suite. Like, how were we supposed to call play game method in Wednesday's lecture? Possibly an example. So how do you call play game in your test suite? That's what my bonus slide here was saying. So this would be inside your test suite itself. Inside your test case, which is inside your test suite, you would create 2 teams to set up your test case, and then call referee. I would have to import execution. I would have import execution dot team and referee in braces to make sure I have access to them. And then once I have access to them, I can say referee dot, because referee is an object already. There's only one referee. I can say referee object dot methods. And the teams, if the team had a method, I would do T1, because team is a class. I can't call methods through the class. Well, I mean, you can, but let's um, and then do T1. For example, like math.abs, you're calling a method through the class. Um, oh, no, no, that's not even true, because that's a static class in Java, which is equivalent to an object in Scala. Yeah, never mind. So with team, we can't call methods through team, even if there were any, because it's a class. We can't call methods through a class. We have to create objects of that type and then call methods through those objects. But here we do referee dot to be able to call them in this one. Just like we did before we knew about classes, those first two LQs 1.1 and 1.2, where we were testing methods written inside a object instead of a class. And Unity is nothing but 3D. So even if you want to make a 2D game in Unity, it's still a 3D game running off the 3D engine, for what it's worth. What is rhyme length? So intuitively, rhyme length is how many syllables rhyme. So usually the standard definition for rhyme is all the syllables rhyme, I believe. I don't even remember anymore. I've been using this definition for so long. But rhyme length is how many syllables are rhyming. So, like computerizing, theorizing, with a rhyme length of 3. Computerizing. Computerizing. So rising, theorizing is going to be that rhyme length of 3. So that's saying all of these are the same, ignoring the stress of the vowels. That doesn't come into play on this example, but ignoring stress of vowels, all these, this is the matching suffix, and there's 3 vowel sounds in there. So we have 3 syllables that are matching. And you can look at these pronunciations and kind of get an idea of, get a good feel of these pronunciations. Every vowel sound indicates a syllable. So this is computerizing. So each time you hit a vowel, you hit a new syllable, and the rhyme length is the number of syllables that rhyme, which we are indicated by the vowel sounds. Every time you hit a vowel sound, that's another syllable that rhymed. And the stress doesn't matter. So this IH2 and IH0, we're considering those to be the same. We're considering those to match for our rhyming purposes. So telecredit, accredit, it's a rhyme length of 3 because from the accredit, it's the same syllables for our purposes, for the homework. Oops.
Asking out your crush can be a crap daunting.
I don't want a risky click today. Is there a grade we get after we pass the learning objectives, or do we get straight A's? Check the syllabus on that. You have to complete all 5 learning objectives and the 8 application objectives to get an A. There are charts and stuff. You can check it out. That's what I don't get. I'm happy y'all stay. I won't harp on it because you're the ones who are staying, and it's 4:42 time almost. But for how many people are struggling in this course, I mean, even I did glance at it during lecture. I think we were only like 120 or so. If you're struggling in the course, like, lecture is the first thing you go to. I don't even mention that to students because it should just be obvious, like watching lecture. So I have hopes, like my optimistic side says, well, maybe everybody's watching it, watching the VOD and still catching up same day. That might be the case. I like to think it is. But, something inside me says, come on, that's way too naive. But at the same time, if you're already behind, watching the current lecture might not help too much. At least that might be the mindset of those students, so whatever. But I'm happy that a lot of you are staying for this. I'd like to see 100% stay for this. I'd probably get fewer questions in office hours. Q would probably be a lot shorter in office hours if everybody just watched lecture and stayed for the Q&A and asked their questions.